Good morning, students. So I welcome you in the digital VLSI subject, digital VLSI subject. So in this VLSI subject, what we'll do, we will see the static CMOS, then dynamic CMOS, pseudo CMOS. These are the syllabus point of view. So what exactly MOS that we will see first? Okay. So MOS is nothing but the metal oxide semiconductor, and we are using the MOSFETs for that one. So design any IC, design anything, you just know what exactly mean by MOSFETs and all. So we'll see the MOSFETs. Okay. So directly I will start with the MOSFET, not with the JFET down or all. So as far as MOSFETs is concerned, there are two types of MOSFET. We know that depletion type MOSFET and enhancement type MOSFET. So what exactly mean by depletion type MOSFET? So normally in any MOSFET, any MOSFET, there is three terminal. That is nothing but the drain. First is nothing but my drain. Then I'm having source, and the third is nothing but my gate. This is nothing but my controlling terminal. This is nothing but controlling terminal. And we know that the MOSFETs are nothing but the voltage control device. That is nothing but the voltage is controlled to flow the current. The current is flowing through this drain and the source, same current is flowing through this one, is controlled by this gate terminal. So whatever the voltage across this gate is controlling the current flowing through drain and source over there. Current is flowing like this one. From drain, the current is flowing from N channel, N channel, N channel. Here the drain is current. And this gate is controlling this current by applying some voltage over there. Okay. So normally here if I am observing this construction of this, so here the source terminal is connected via one metal patch over there, and then that metal patch, the black, whatever the black portion is there, that metal contacts are there. That is connected. That is connected to the N channel, N type material. We can say that N type material. The drain is also connected via the metal via N channel, and that is two are interconnected by using one slab of N channel, that is nothing but the channel over there. So here is the channel of N over there. So that over that you will find a line over there. These kind of lines are there. This is nothing but the SiO2. So SiO2 is nothing but my oxide layer. Okay, oxide layer. So it is highly insulating material. Okay, highly insulating material. So there is no contact directly in between this gate terminal and the channel over there. There is an insulation in it. So this will act as a capacitor. You can observe this as a capacitor. Here is what you can say, a connecting material over there, and here is the metal also conductor over there. So and in between insulating material there, so it will act as capacitor over there. So that's why we have seen this construction as MOS capacitor, as MOS capacitor. Okay, this is the simple construction of the N channel depletion MOSFET. So in depletion MOSFET, what is the difference between depletion MOSFET? Depletion MOSFET, your channel is already present. In the enhancement, the channel is absent over there. So we'll see the operation how it works. So normally in first case what we are doing, we are connecting this gate terminal to the ground. That is nothing but we are not applying any voltage across this one. And the drain and source are connected to the supply, that is nothing but VDD supply. So here my positive terminal is there, and here battery terminal is my negative terminal. Okay, the substrate is common, I will connect to the ground. Then what will happen? Here is a positive and here is a negative. So is as positive terminal is connected over there. So what will happen? We know that electron will attract over the positive terminal. Yeah, it's attracted. So electron will flow like this one. Electron will flow like this one. You can observe. You can see the electrons flow by direction. And the current is opposite to flow of electron. We know that current is flowing opposite of electron. So current is like this one. The current flowing through this is ID, and current taking out from this is IS. So similarly, color is flowing through this is nothing but ID, and this is nothing but my IS over there, and that is nothing but the saturation. So maximum current, whatever the flowing through this, is nothing but my saturation current. So whatever the voltage we are maximum voltage, maximum current. If I am applying 1 volt, so near about 10 electrons are attracting. I am saying, okay, this is a typical value I am saying. Typical means what? That is not at all final one. It may be 100, it may be 10, it may be 20 or 30, 40, like this one. Typical value. So if I am applying ID over there, so what will happen? Electron, 10 number of electrons. Suppose 10 electrons. If I am applying a 22 volt, then what will happen? 20 electrons will happen. So number of electron will increase it, number of current is increasing. The quantity of current is going to increase. So whatever the current is flowing through this, it totally depend upon the how much voltage you are giving at this terminal. So if you are applying more voltage, more amount of electron will flow, and which will cause a more amount of current cause to flow. Yeah. So this is nothing but the basic operation of depletion MOSFET, N channel MOSFET. Okay. When VGS is zero. So now what will happen in this case? In this case, if I'm applying a negative voltage to the gate terminal, negative voltage to the gate terminal, then what will happen? The electrons are flowing through this channel. We know that n channel is there, so electrons are there. Okay, and here the substrate is of p channel, that is nothing but holes are present, are there, holes are present over there. So as we are applying a negative voltage across this terminal, so what will happen with this electron? They are getting attracted or repelled. As we know that electrons and the negative are the similar polarity, so electron will get repelled. This electron will get repelled and they will get attracted toward the holes, as holes are nearby. So what will happen? These holes and the electron will recombine. Okay, these holes and electrons will recombine by applying some voltage. Suppose I am applying a minus 1 volt. So 1, 2, 3, 4, and 5 electron will recombine. Once we know that electron will recombine, then it will not take part in the conduction. That means the current conduction will get reduced. Current conduction will, what will happen with the current conduction? Reduce. Then suppose in this case there are 100 electrons normally. Okay, 100 electrons are there. If I am applying 1 volt, 10 electrons are there that are got in the recombination process. If I am applying minus 2 volt, then what will happen? Again 10 electrons. So 20 electrons are there in the recombination process. So 80 electrons are there which are carrying the current. 80 electrons are there in the current. That is nothing but previously we are having 100 electrons when there is no VGS. As we are applying a negative voltage at the gate terminal, then what will happen? As we are increasing the quantity, the recombination process is increasing. So if I am applying minus 5, then 50 electron will get recombined, and we are having 50 electron that will carry the current. So the quantity of current is going to be reducing by applying a VGS. Then if I am further increasing the VGS, then what will happen? My this this combination recombination process is again stimulated, increasing. So at certain voltage, what will happen? Whatever the electrons are there, they are totally get recombined with the holes, and the zero current will go. The voltage at which the current is zero is called as pinch off voltage. Okay, it's called as pinch off voltage, and that is a part of VGS. Okay, part of VGS. That is nothing but VGS is VGS at which your current is zero is called as pinch off voltage. It's called as pinch off voltage. You can say that threshold voltage. I can say that. Okay. Now you will get the concept. So this is the waveform of this. So how to read this waveform? How to read this waveform? First of all, in the depletion mode, if the voltage, this VGS, is 0, you can apply a 0 over there. So here you will see the maximum current 8 milliampere. So that is nothing but the IDSS, that is nothing but the maximum current is caused to be. If I am applying a negative voltage, then what will happen with the current? Current is caused to be decreasing. Current caused to be decreasing. Why? Because of a recombination process, and it is going to be recombined. Okay, likewise it will go recombine, and at the minus 6 volt the current is 0. Minus 6 volt is current is 0. That voltage is called as VP, that is nothing but the pinch of voltage. What is nothing but pinch of voltage over there. Okay, so this is nothing but my pinch of voltage. So I think you got the concept. Likewise, if I am drawing the waveform for ID versus VGS versus VDS versus ID, then at the 0 voltage, minus 5 volt, if I am applying first of all 0 VGS 0, then as we are applying VDS, current is going to be increasing, current going to be increasing, current going to be increasing, and at certain voltage, that saturation, the current is near about flat. As we are applying a negative voltage, then current is decreasing. Here you are observing current is decreasing, here current is decreasing, current is decreasing, current is decreasing. So like this one, at VB the current is normally zero, normally zero. So how to remember? What you have to remember in the depletion MOSFET, if you are applying a negative voltage for the N channel, negative voltage for the N channel, then what will happen? Your device will get shut off. Your device will get shut off. Okay. And in case of P channel device, here I think if I'm having P channel, okay, P channel is not there. So P channel device is there. So we have to apply a positive voltage. So whatever the channel is there, that amount of voltage if you are applying, that is N channel negative voltage, your device will get shut off. Okay. If P channel is there, positive voltage, your device will get shut off. Like this one, you have to remember the things. Yeah. So depletion MOSFET, the current is given by ID is given by IDSS in bracket 1 minus VGS upon VP bracket square. So IDSS is nothing but my saturation current. IDSS is my saturation current. VGS is nothing but the gate to source voltage. And VP is nothing but the voltage at which your device will get shut off. Okay, current will not flow and square. Okay, so enhancement MOSFET. So in the enhancement MOSFET, what exactly how to remember this? If here here if the channel is absent over there, the channel is absent over there, so whatever the resultant device is called as my enhancement MOSFET. So if I am applying a negative voltage across this terminal, okay, negative voltage or positive voltage at this terminal, positive voltage at this terminal, then what will happen? Here positive part is there, so here positive is there, so electrons are get attracted, so electron will get attracted and they are forming one bridge over there, they are forming a bridge over there, and due to which current cause to be flow. So how to remember? P channel, if you are applying positive voltage, then the device will get on, and if you are applying a negative voltage, the device will get off. In the N channel, if you are applying a negative voltage, your device will get off, and if you are applying positive voltage, your device will get what? On. So like this one, you can remember the things. Okay. So we'll see the symbols of this one. So how to remember the symbol? It's all about arrow. Arrow is inside, that is nothing but the N channel depletion MOSFET, and arrow is outside, that is nothing but the P channel depletion MOSFET. So I think we will stop. Okay, this is the enhancement MOSFET. So channel is upset over there. The channel is upset over there. Okay, and the remaining everything is same. What is the same? SiO2 layer in between these two, and the metal contact directly connected to n doped region over there, and the source is connected to one of the n doped region, and drain is connected to one of the doped region, and the gate is connected to the SiO2 layer over there. So they it will act as a capacitor over there. And if you are applying some potential, positive potential over there, I have already mentioned that. So whatever the P channel is there, electrons are attracted over there, and they are forming a bridge over there. They are forming a bridge, and due to which current cause to flow. Current cause to flow. The voltage at which current cause to flow, that is called a threshold voltage. Threshold voltage over there. Okay. So this is all about, okay, this is all about the MOSFETs and all. So in next lecture we will see the static CMOS, dynamic CMOS, pseudo CMOS, how to what you can say form an NMOS, PMOS. We will see in detail. So thank you very much for attending this lecture. Thank you.